when you're ready. I know. So, hold on a sec. I want that one. Okay, is that coming up? Can you see the notes at all?
No.
No. What's happening here? Don't know why. Here we go again. What's happening there? Try again. Oh, here we go. How's that? Can you see the notes now?
Yeah.
Yeah. Yeah, okay. All right, well, I'll just start reading through this, and if you've got any questions, just interrupt me at any time, and we'll have a chat. So, as we've been discussing before, air conditioning and mechanical services systems will always generate noise. So, whether it's a fan or a pump or an air conditioning compressor, noise will be generated, and it's really a matter of, is that noise source an issue or not? Air velocity in ductwork, duct fittings when air's going around bends or through transitions, etc. That can create noise. It creates turbulence in the airflow, which generates noise. And also vibration is a source of noise. So generally, you'll hear the noise generation and control is just referred to as acoustics for our systems. So if we say, have you looked at the acoustics? That's what we're talking about. Have you looked at the noise sources and whether they're going to be an issue? Excessive noise in buildings is a nuisance, and we have to do something about it. That's not to say we have to do something about everything. We just need to be aware of what the noise sources are and whether they are going to be an issue for the project. And different types of projects have different noise requirements. Some mightn't have any noise requirements at all, but generally office buildings, apartments, the types of buildings that we work on generally do have considerations for noise. So I need to be aware of that and make provision for reducing the noise levels where we need to. Most projects that you guys will work on will have if there's a consultant involved, there'll be a mechanical specification, and there may even be an acoustic specification. Sometimes the project team will include an acoustic consultant who will provide his own specification of requirements. So just look for that in the documents. It's quite common these days to have that acoustic specification. So we just need to have a look at that and comply with those requirements. The specifications will normally include maximum sound levels for the various spaces in the building. If we don't get that, if that's not included, the Australian Standard AS 2107 provides recommended sound levels for many different areas. I think you're aware of this standard, aren't you? You've had a look at it. It's got tables. I can just quickly put that up if you want to have a look at that again. So these are the tables that have recommended sound levels for various types of buildings, and probably would cover most things that we work on, if not everything, but probably just about everything.
Peter, I'm actually working on a job at the moment where I'm using the acoustic report.
Yep.
So it'd actually be good. It's a pretty short one. We could just, if I could pull it up and we can just go through and identify, the components of it.
Yep.
So I haven't looked at very many of them, so I don't know.
Yeah, sure. Yep. That's
comprehensive.
Perfect, yeah. Okay.
Yeah. All right. I'll just share my screen now then.
Do I need to stop sharing? I suppose I do.
No.
Okay. All right.
Okay. Yep. So it's by this company, Soundbase Consulting Engineers.
Mm-hmm.
So they have 3 different acoustic wall ratings.
Okay.
Wait, sound reduction index 40, 45, 50.
Is this the job where you've been talking about acoustic penetrations or penetrations
Yeah,
of acoustic walls?
yeah,
Okay.
exactly. Yeah.
Right,
Yeah.
okay.
It's like they describe the
Oh, so they describe what they are, yeah.
they
Okay.
are.
One layer. So right, and are they clearly shown on drawings?
Yeah,
These
a little
where
bit
these
further
walls
down
are?
they've got
Okay. So they've got drawings as well, have they, indicating where the walls are, or is that in the architectural drawings?
so yeah, they're in the
Oh, I guess you're breaking up. I can't hear what you're saying at the moment.
okay. No, these are the architectural partition plans here, with also the color coding, the different acoustic ratings.
Okay. Yep. Right. Okay. And have they given you a detail of how they want the penetrations to be sealed?
The consultant has, yeah,
Right. Okay. So packed cavity with rock wool or polyester acoustic insulation. And then the, what's that, minimum 1.2 thick steel angle collar fixed to the duct and flexible mastic sealed to the wall. Okay. So that's, is that the same for every acoustic wall?
yeah. They haven't, yeah. This is just the one detail.
Yeah, okay.
And then they also include. Okay, so this is just about the partition.
We
It's a pretty short report, actually. Like,
so they don't talk about duct velocities at all.
no, no,
Um, they don't talk about sound levels in spaces.
no. Like it's just 11 pages. It's and a few of them are doubles. It's really just these 3 kinds of partitions.
Okay.
Uh,
So where they're designated as they've got a rating, an acoustic rating,
yeah,
then any penetrations through those walls have to be done in the way that they've asked for. But in terms of sound levels in spaces, you'd have to refer to AS 2107.
right. Okay.
If they haven't nominated that, I mean, what you can do, and probably not a bad idea, who are you working with on this project?
What do you mean?
Who's the client?
There are chill merchants up in Brisbane.
Contractors, aren't
Contractors, yeah.
they? If nothing is specified, well, in the is there a mechanical specification?
Yeah, there is. Like, this is a construct only job, mind you.
Yeah, okay, but the mechanical specification should be give you a guide on what the requirements are in terms of sound levels in spaces. If it doesn't, then probably the best way to handle it, I would suggest, would be to issue an RFI. If there's nothing given there, say in your RFI, you could say we will refer to AS 2107 to determine, okay, noise levels 26.
No, it's not one of them.
Oh, there you go.
Yeah.
Nice. Meeting rooms 30 dBA. That's pretty quiet. How are you dealing with, what sort of air conditioning system have you got for a meeting room? Is it a separate unit?
They've got cassette units. Yes, separate cassette units.
Okay. So I chuckle because a cassette unit won't give you 30 dBA. So this is one of the risks that you fall into with design and construct. So the consultant has shown cassette units in the ceiling of the meeting room, and then they ask for 30 dBA. If you look at the sound level of a cassette unit, it's probably more like about 45, if you're lucky.
Well,
So
yeah, these are the meeting rooms. Yeah.
right, so you've got an outside air duct, unconditioned, I presume,
Correct. Yeah.
putting fresh air in, and then you've got a cassette unit. If you were to look at a typical cassette unit, if you looked at Mitsubishi or Daikin or something, and have you got any data on those handy? And had a look at the tech data on the sound levels or the technical data sheet or specifications.
Um, yeah, I don't know the model, like what the model number for the
Well,
cassettes is
it's
off the top of
typical
my
of,
head.
I mean, the bigger they are, probably the noisier they get, but um, basically it's just a fan. The compressor is outside, but so each cassette unit is going to have a fan in it, and it's the fan noise that's going to be the issue.
Later. We're gonna
You haven't got the
be in there.
yeah, it might take a few minutes to find something, but you could have a look at the oh, what do you got there? Ceiling cassette A3.
Here we go.
Righto, so this is what capacity are they? Indoor unit.
Oh, it's 2.5.
Is that all you've got in the meeting room? Just 2.5?
No, I think we got more than that, but this is just
All right. Well,
first
if you
thing
look
I
at
pulled
that,
up.
if you look at a 2.5, that'll be the quietest because that'll have the smallest fan probably.
Yeah.
But you can look across when you get down to sound levels. So sound, there was something there on that data sheet. That specification sheet further back, I saw sound levels, so I was about to read across, and then
okay.
you kept going. So up the
Yes.
page somewhere. Stop. Yeah, just yeah. So down here, if
Sound level here.
you can see it there. So it says SPL. You know what that is?
Sound power level.
SPL is
Pressure.
sound pressure level. SWL is power level. W meaning watts for power.
Yeah.
P for pressure. So dBA 25 to 31. Okay, so the small one might do it. And then you go to the next one, it's 25 to 39 and so on, 27 to 39, 32 to 43. 32 to 43 would be, is that a 6 kilowatt unit? It is probably around, the 60 is probably about a 6 kilowatt unit. So you can see that that may be an issue if they want to achieve 30, was it 30 dBA they wanted, was it, or 30?
Yeah, 30.
Yeah.
Just check what
I
else.
would say from experience anyway that when you've got an exposed unit like that, it's going to be very difficult to achieve those low noise levels, and probably not really necessary anyway. But they've specified it, so you're saying that's a requirement of the project.
Yeah, okay. Now I'm curious about what capacities we selected for those rooms.
For the cassettes that you just had listed there, if you were to choose the lowest one, it obviously ranges from like 25 to say 31. Do you specify that you'd only have it running at like a low level? Because if they like operate it at different levels when they have it installed?
They have different fan speeds. That's what that means.
And
So
will it be up to the people that are in the building to, control that? Or is it something that's set and not touched again for cassettes?
either way, they'll have a control on the wall,
Yeah.
which they can fiddle with. But by the same token, when we commission it, we can probably set it so that they can't fiddle with it. But
Mm.
you have to achieve the capacity. So
Mhm.
if you need the high speed of the fan to achieve the cooling capacity, then turning it down, it's not going to give you the capacity when they need it at full load.
So if you select a unit and then you say at the lowest capacity, everything's achieved, and that's also going to be within the specification for noise, that's fine. Even though it could potentially get loud if they put it higher, you've specified that it
Yes.
only needs to be on the lowest.
And
That's
you
okay.
need that needs to be documented in some way so that you're covered. But if they
Yeah.
come back and say, "Oh, this is not acceptable, it's too noisy,"
Yeah.
as long as you've told them that you've selected it for that speed, and if they choose to turn it to a higher speed, then it may exceed the specified sound level.
Right. Okay.
So you can do that, but
Yeah.
so you're sort of covering yourself, but it just becomes a big argument, that if someone decides to turn up, they'll say, "Oh, why can't we turn it up? We want more air," but it's noisy. Well, yeah, of course it is. It's a really tricky one. I can't give you a very good answer, I suppose, but the best you can do is if that's the unit you're going to select and you're happy that it satisfies that specified level, then you need to put it in writing through the system so that there is a record there that you've told them and you've covered yourself.
Yeah.
It doesn't mean you won't get dragged in later on to try and sort out what the problem is, but you can say, "Oh, well, just refer to what I sent you before," but that's they're not always satisfied with that because they don't read the documentation. And anyway, I
Yeah.
won't.
Anyway, I just checked, and I think we'll get away with it because this is like a 5.6 kilowatt unit, and it goes from like 25 to 31. So
Okay.
yeah, I think it's okay.
All
in
right.
terms of,
Well, that's good.
yeah. Okay. Anyway, does this acoustic report, it seems like a little bit too brief. Does it? Would you have expected more
Well, yeah,
about the
obviously,
mechanical?
usually an acoustic report would have mechanical stuff in it, but maybe that's just been written for the architect to show the architect
Yeah, it is.
how they need to specify the walls.
Yeah, it is an acoustic partition markup.
Okay, so
Yeah.
it's not a mechanical or it's not a general acoustic report for everything.
Yeah.
And so then you refer back to the mechanical spec, which tells you they want 30 dBA in the meeting room, and then you need to make sure that our systems can achieve that.
Mm-hmm.
What I was going to say earlier, so you've got the documentation there. I was going to say, in the absence of that documentation, if you don't have anything like that, if the mechanical spec doesn't tell you what the sound levels are, then you'd have to put an RFI in the system and just say, we've looked through the documents, we can't find anything that's specifying that sound levels required in the various spaces. Please advise what's required. Otherwise, if you don't provide this information, and you can give them a time frame, just say, look, if you don't tell us within a week or within whatever time frame suits you, then we're going to rely on AS 2107 to allocate noise levels to the spaces. But then you probably need to tell them what you've selected. So you can say for a meeting room, you can look in AS2107, for instance. And if I just scroll down on my screen, for an office building,
You can share it.
board and conference rooms, it says between 30 and 40 dBA. Oh, sorry. So I take the screen again?
Yep.
Right, okay. So here we've got board and conference rooms, 30 to 40 dBA. So you could say that gives you a little bit of leeway. And so that's what we're going to design this system to, and select the equipment to be suitable for that sound level, being we won't exceed 40 dBA. But the mechanical spec in this case has said 30 dBA. So that's, that makes it a lot harder for you to achieve.
Mm.
Yeah, okay.
All right, thanks for that segue.
Anything else on that?
No, not really. I mean, the question I had around it was like, do we need to nominate every acoustic penetration on drawing? Like, there are a lot of acoustic partitions and there are a lot of penetrations, but Phil said that for like non-blockwork walls, at least my understanding was then like non-blockwork walls, they just build the wall around the mechanical equipment. We don't need to explicitly nominate penetrations.
No, because it really comes under builder's works when you're going through masonry walls, blockwork or concrete. The builder who's building those walls needs to know so they can build it in, because if they build a block wall and then you say, well, I need a penetration in the wall, then they've got to start knocking bricks out of it. And that's a very messy job. If it's concrete, it's even worse, because, you can imagine trying to cut a hole in concrete after it's been poured to make a wall. So they need to know as they build that, and then they'll block it out and work around it. Yeah, so that's correct. If it's just a material they can cut as they, like plasterboard or villa board, they can cut it as they fit it to the walls.
Yeah.
Around the ductwork, and then we'll have to pack around that with the insulation and put the angles on to seal it. Okay. Just on your job, Jess, the other thing in that meeting room area is you've got that fresh air fan or outside air fan putting outside air into the space. You have to be aware of any noise that might come through that system as well.
Yeah. Yeah.
And that's another noise source. I said last week that noise sources are additive. Okay, so if you've got a noise source, the cassette unit is, let's say 30, it's already 30 dBA, but you've got another noise source from the outside air, which might be another 30 dBA. And the result of that, if they're the same sound level, and depending on how far apart they are, that will increase the noise level in the space.
We have some acoustic attenuation like lining on this duct.
Yeah.
And then it is located pretty far from the space, and there's some like a bend and flex. So how do you think that would go?
It's probably okay. It's only a small fan, isn't it? It's
yeah, it's like 30 liters a second per room.
Per room. What's the total?
150. And yeah.
Yeah, okay. So it's just an inline centrifugal type fan.
Yeah.
Fair bit of duct and some internal insulation. So I'd say it's going to be okay. I didn't want to create alarm. I'm just trying to make you aware that, you've got another noise source to that room. So if that's the situation, just have a look at that as well. If you're comfortable with it, that's fine. You can have a look at the net noise level of that fan. And you've got a fair bit of duct anyway, so you'll get some attenuation from that.
Yeah.
So yeah, look, it should be okay. All right. We'll go back. Now, go back. I'll share mine. Hang on. All right. Got the notes back now?
Yeah.
So in that paragraph I was just talking about, OS2107, the last sentence there, this standard isn't referenced in the NCC, so it's not mandatory. So that means you don't have to do it. It's kind of negotiable with your client, whoever your client may be, whether you're going to comply with that standard. But it's a guide, and generally speaking, we should use that as a guide. And if we refer to that standard, we've done the best we can. Does that make sense?
Yeah.
Rather than just pick a number out of the air and say, oh, well, it's a meeting room, let's make it 40 dBA. If AS2107 says 35 dBA, then use 35. Because it's something that, something we can use, which is an accepted standard. I just made that comment there because this is another awareness thing for you guys. I think I've talked about all the standards that are included in the NCC. There's a table there. I think it's called Schedule 2, which lists all the Australian standards that are referenced in the NCC. So if they are referenced in there, you must comply with them. There's no flexibility there.
Mm-hmm.
And that can be very important in certain situations. So you're working on a project. Sorry, I'm digressing a bit here, but just to give you a bit of background. If you're working on a project that was designed 5 years ago, let's say, and now it's coming to fruition, and the development approval, and this happens quite a bit because people have to go away and get finance, where they say, let's just put it on hold for a while. And say COVID is an example. A lot of projects were put on hold during COVID, while people waited to see what was going to happen, and they couldn't get labour to site and things like that. It was just too difficult. So they shelved the project. And when you start again, they're referring back to the NCC of, say, 2017 or 2018 or whatever it may be. So that once that project has been approved, the NCC that was in force at the time is the one that applies. And so the NCC of that time might refer to a standard which was written in a different year to the one that's current. You know what I mean?
Yeah. So is it at what point is or in what document is it agreed upon which NCC, if there's, if it's kind of between like reissues of the NCC, or if it's ever contentious, is it ever?
It's basically the development approval, which you have to ask for. You're not normally issued with that. If it's a project that was designed a few years ago, then it's probably worth asking. With an RFI, just say if it's a design and construct. If it's construct only, then just do what the documents say. But if it's design and construct, then you need to know what is the relevant approval for the project.
Yeah.
That's just a little complication that just to be aware of. So I've mentioned here the figures quoted in AS2107 are expressed in dBA, which is an A-weighted overall sound pressure level. Did you have a chance to read the notes I sent you from Fantech? I sent them last week. Anyway, have a look at that when you have a chance. It talks about sound pressure level, sound power level, and dBA and things like that, which are basic. So I didn't want to go through that now. You can have a look at it in your own time and get a better understanding.
Mm-hmm.
The dBA levels are approximately 5 dB above an NR level. So there's NR curves in that Fantech document that I sent you. Quite often they'll refer to NR as the required rating level for a space. They might say they want NR 40, say. So if it's NR 40, then the dBA would be 45. that's generally accepted that they're about 5 dBA. That if it's NR40, then it's going to be 45 dBA. And the reason they express them in dBA because they found out that, or worked out that that closely represents the sound that we hear. So they're trying to make it real, so that if it's dBA is what we actually hear. Okay, so equipment. All HVAC systems which move air require fans, obviously. Fans and motors generate a certain level of noise depending on factors such as the fan type, size, speed, system pressure. So generally, as the fan gets bigger, it gets noisier. If you speed it up, it gets noisier. And if you put it under a lot of pressure, it's working harder to achieve the pressure and it gets noisier. So those things are all factors. And the noise generated by the fans enters the occupied spaces in two ways. I could add another one, which I will in a second, but via the ductwork and the grills, so you know that, you're aware of that. Also from breakout from the fan casing and ductwork. So you've got a sound power level or sound pressure level. Let's talk about sound power. The sound power is generated by the equipment. Some of the noise that's in the ductwork can actually break through the casing of the fan and the ductwork and create noise issues. But generally, that's not our main problem. The main problem we've got to deal with is through the ductwork and the grills. But there is another one, which is vibration. And I'll talk about that a bit later. Vibration is a very tricky thing. If a fan is vibrating and causing vibration in ductwork, the ductwork is supported from the structure by rigid supports, which is normal. Then the vibration in the ductwork can go through those supports into the structure, and that starts to set up vibration in the structure. It's only minor, but that can show itself as noise in a space. And sometimes I've been in a situation, I can remember it now, where we were trying to achieve a certain noise level in a new building, and everything through the ductwork was fine, but there was a vibration that was, and we had to lie on the floor and put your ear to the floor to feel the vibration. It was that vibration that was causing us to be a bit above the required sound level. So it's a bit strange, but so what we need to do is remove the vibration from the ductwork and pipework. And I'll talk about that a bit more later. Excuse me a sec. I've said here acoustic calculations can be carried out to determine the effect of fan noise on the occupied spaces. So we talked about that quite a bit last week with your job, Jess, or the week before.
Mm-hmm.
And if necessary, we need to make provision for mitigation of fan noise to ensure that the required sound levels are not exceeded in the spaces served. So that's obvious, and you're becoming aware of this now. It's over time, you get a feel for it. Okay, you start to get a feel for what's the fan noise, how much ductwork have we got, do we need a bit of internal insulation? You don't always have to do acoustic calcs, but in the early days when you're learning, sometimes it's going to help you to do the acoustic calcs, and just so you get a feel for what you need to do and whether it's going to be an issue. All direct expansion air conditioning systems include one or more compressors. For an air-cooled system, the compressor is normally outside in the condensing unit. Excuse me. So that the condensing unit's got the compressor, the condenser, and a condenser fan. So that creates a fair bit of noise outside the building. Water-cooled package units have integral compressors and are normally installed inside the building. Have you done any water-cooled jobs yet? Water-cooled package units?
I've looked at them, but I haven't really done one.
So they're commonly used. I guess obviously not as common as air cooled, but water cooled can be very useful for buildings like maybe an educational building where you've got lots of rooms, lots of classrooms, and if the architect or the client doesn't want to see a whole lot of condensers outside the building or on the roof, then you can put in these water cooled package units. But if you have those, you're bringing the compressor into that indoor unit, and the heat rejection is taken away by water, so condenser water. But then you need a cooling tower or a fluid cooler. You've got to find somewhere to put that. But you may have only one cooling tower for the whole project, which serves all of those water-cooled package units, and that can be convenient. So if you have a water-cooled package unit, they do make a bit of noise. I did a job in Sydney 5 years ago. It was actually a refurbishment. The original building had water-cooled package units in all the hotel suites, and it was noisy. It was very noisy, and they were trying to achieve, 30 dBA in a bedroom, a hotel room. No way, you just can't do it. So we ripped all those out, and we put in a different system, which was just fan cool units connected to a chiller. But you'll come across those water cooled package units, and we may have a session where we talk about those sort of units. If you're using air cooled systems with external compressors, so if you've got a whole lot of condenser units outside, you need to give consideration for sound control for both the property that you're working on, so the project, but adjoining properties as well. So if you're doing apartments, for instance, you need to be aware of the noise that's being generated by those external units and how it might affect the neighbours. Or a house, if it's just doing somebody's house, you're putting units outside, how is that going to affect their neighbours? When we're using water-cooled systems with internal compressors, consideration for sound control must be given to the occupied spaces served, as I was just saying. Try to locate these water-cooled package units outside the space served. So put them in an adjacent room which is not occupied. For instance, if it's a school, they used to be quite popular for schools and university buildings and things like that. Try and put them into an adjacent space that's not occupied normally, and then put some attenuation in the ductwork, internal lining. That hotel that I mentioned, we had to look at wrapping the units with insulation as an option to try and take out some of that compressor noise.
Is internal lining better for like what types of sound attenuation versus say external?
With the water-cooled package units, the compressor noise is actually it's a breakout noise, because it's the ductwork. You've got a supply air fan, which in a normal way pushes the conditioned air through the ductwork, but the compressor is in a separate compartment of the water-cooled package units, and so that's generating noise which is breaking out of the unit and then breaking through the ceiling into the space, and the noise level of a compressor might be 50 dBA or even more, 50 or 60 dBA. And so you've got this noise breaking out. It's attenuated on the way, breaking out of the casing, you lose a bit of sound power. Breaking through the ceiling, you lose a bit of sound power, but they're still often too noisy to be acceptable. So if you wrap the casing or wrap the line the chamber that they're in, then you may be able to mitigate it that way.
Right.
So yeah, just be careful, be aware of it. So air velocity and ductwork. So we sort of touched on this before. Some specifications will talk about the maximum allowable velocities in various parts of the air distribution system. Have you seen anything like that? Specification with velocities in it?
I haven't personally.
Okay,
That would
well,
be in the mechanical spec or the acoustic?
yes. Well, both, either or both. Yeah, no two jobs are the same, as you probably found out already. But you've got
Yep.
different consultants, you've got different acoustic consultants if they're involved. They do things in different ways. So it's just you need to find out what documents apply to the project or what's in existence. There may not be an acoustic specification or report. So you just need to look at the mechanical spec. If there's nothing in the mechanical spec, then you need to use your own judgment about what suitable velocities are. But you also need to take note of the NCC because that has requirements on ductwork as well in Part J6D5, which I'll mention in the next paragraph. I found this in somewhere, can't remember where I found this, but this is just an example for low velocity duct design, up to 500 pascals duct pressure. They specified these velocities. Now this, don't take this as something as a guide, well, it's a guide, but don't necessarily use it, but this was just what they specified for a particular project. So for NR50, you can run your ductwork, run the velocities up to 10 meters a second. For NR30, you have to drop it down to 5 as an example. And return air velocities are reducing as you go down in noise level. Velocities need to reduce as well to keep the noise down. Ductwork in plant rooms and risers would normally be sized for up to 10 meters a second, provided the friction rate is acceptable. So again, that's the NCC. You've got to comply with the requirements there, which is 1 Pascal per meter in the index run. You'll find that as the velocities increase, the ductwork is getting bigger. Usually, if in a riser or a plant room, the duct is bigger. Achieving 1 Pascal per meter is not usually a major problem. And I put down a few typical recommended sound levels there, which offer spaces typically NR35 to NR40, which for dBA, if you're looking at AS2107, it'll say 40 to 45. Residential areas, 35 to 40 dBA, depending on a bedroom, would be different. Obviously, if you're going to run air conditioning at night, it needs to be quiet. So for a bedroom in a residential building, you might be trying to achieve 30 to 35 dBA like that meeting room. And sound studios can be quite low. So if you're doing a film studio or a sound studio, they will have stringent requirements, and that's when you need to look at it closely. But if you're doing a project like that, there would normally be an acoustic consultant who will dictate what they want in the project. So they'll tell you the velocities in the ductwork, they'll tell you the sound levels and the space. They might even go so far as to give you design information on how to go about designing a system. And if that's part of the documents, then that's what you need to follow. I did a project at RMIT, probably 10 years or so ago now. It was they called it a micro nano lab. Have you guys done anything on nanotechnology?
Yep. Sounds
We,
interesting.
they had an acoustic consultant, and he was very much involved in the project. He was hands-on. He was really good to work with, actually. There was, vibration was an issue, sound levels were an issue, and he went to the nth degree, and we followed it, and we achieved what he was after. And he gave some good examples of how critical it was to achieve, particularly the vibration levels. So we had to do a lot of extra work to. It was all included in the job. We priced the job to suit what he wanted, and it worked out okay. But very stringent requirements. Duct fittings such as elbows, offsets, transitions, tees, branches, etc., can generate noise depending on the type of fitting used and the air velocity. So if you have sharp changes of direction, sudden change in size, they can all generate noise if you've got relatively high velocities. AS 4254 is the ductwork standard. Have you guys been involved with that one at all?
It's been a while since I've probably had a look at it.
Okay. So I don't know what you're using for your ductwork standards. I know in Revit you've probably got standard fitting types. AS 4254 is a guideline, or it's really a specification. It's referred to in the NCC. Tells you how fittings should be made for the most efficient airflow, basically. So I can, and I'm actually thinking that we might go through these standards as one of our sessions, just so you're aware of it, of what's there. There's two parts. Part 2 is for rigid ductwork. So this is just some diagrams in part 2, setting out, how a good way to design ductwork. So they're showing this, it's called a shoe. The branch is a shoe with a 45-degree taper to reduce the pressure loss through the bend. On the some people call them a pop with a spigot takeoff for the flexible duct. They're showing a bell mouth spigot there. I don't know whether they make these anymore. They used to make these. It was like a spun piece of sheet metal, and by increasing the area at all these at these branches, so you're increasing the area of that branch there, increasing the area of the branch here, you're reducing the velocity and reducing the pressure loss at that point. Transition, they're showing an angle here. If we look down at I don't know where that's defined actually. It'll be there somewhere. It's probably 15 degrees as a maximum angle. Recommended for not creating turbulence in the ductwork. So if you have a sharp transition, and we talked about this last week on your job, Jordan, I think, where you had very sharp transitions, and at the inlet to the fan as well. So you're causing turbulence, but then that turbulent air is going into the fan, and turbulent air going into a fan, the fan's not going to work properly. Have you had any further discussion on that with anyone?
I'm still waiting for the acoustic engineer to analyse it.
Yeah, okay. Well, he or she might come back with some recommendations on how you can do that.
Yeah.
So yeah, just skimming down through here, different types of fittings. They give recommendations on angles and dimensions and so on. So all that data is there if you want to refer to something. If you're not sure how a fitting should be made, this is quite a good guide. The Air Duct guide as well. I can't think what number it is, but in the DA guides, there's one volume on ductwork if you're looking for information on how to design duct. This gives some information on offsets. It says here 15 degrees maximum, or an included angle here for a concentric transition, maximum 45 degrees, diverging 60 degrees, and so on. So that information is available if you want something to refer to.
What was the splitter damper a few pages up where we were before? I've never actually seen one on a project.
At the layout drawing.
Yeah,
this one?
Yeah, that, yeah.
Well, where you've got two ducts there, you've got two ducts going in different directions. So there's a kind of a stop end in the duct here, and then it's just giving you the ability. It's really an option whether you wouldn't probably have both. You wouldn't have a volume damper in each branch as well as a splitter damper. But the way a splitter damper works, usually it's just a piece of steel plate, and it has a connection which goes to the outside of the duct with a quadrant on it, like any other damper. So you can turn it. Sorry, you can pull it. It's a push-pull. You have to pull it out and then lock it when you get the desired flow in each direction.
Right.
And you could do it as well as volume dampers to get the sort of coarse control and then the fine control with the OBDs in the ductwork. But to be honest, they're not used that much anymore, because what can happen is because there's a rod that sticks out through the duct, over time with the air flowing over it, you get a bit of a rattle up. They can be a bit noisy because they start to rattle, and the connections can break. And if the connections break, then, the damper is going to go one way or the other and block off the flow through one side. So generally, I wouldn't recommend using those. So even though it shows it here, you probably won't see them. But different manufacturers do things in different ways. So these are just things to help you if you need some help, I guess. Let's go back to the notes. Now, vibration. I mentioned that earlier. Vibration is quite tricky because you don't always know where it's coming from. It can be a major noise source in buildings. Excuse me. Vibration from a fan can be transmitted into ductwork and then into the building structure via the equipment or ductwork support systems. And this can create unwanted noise and vibration in an occupied space. That example that I mentioned before with the vibration in the floor of the office space, that was from the pipework. So there's a plant room below, I think, and the pipework was fixed to the slab, but there was vibration coming through the pipework and through the slab, setting up a bit of vibration in the slab, which was then creating noise. So what we had to do was isolate the pipework from the slab by using flexible mountings, and that solved the problem. Normally you don't need to do that, but sometimes it does happen. Flexible connections and vibration isolators play a crucial role in HVAC systems by reducing the transmission of vibration between the mechanical equipment and the building structure. They act as a barrier to the transmission of vibration. Did you guys study vibration at uni?
Yeah.
Enjoy it? It's
difficult, but it was nice when you actually understood it. It was quite rewarding. Yeah.
It's quite complicated, isn't it?
Yeah.
And I remember when I went to uni, which was an awfully long time ago, but I think vibration, we had a complete semester on that. It was probably the hardest thing that for me when we studied it, to understand how to do the calculations and how it all worked. But it's interesting. Vibration isolation of equipment is normally achieved by supporting the equipment on resilient mounting such as springs or rubber, which compress under the equipment weight. So you would have seen this. For fans, you can use either rubber mounts or spring mounts. Pumps are normally mounted on springs, quite often with an inertia base to absorb the when a pump starts. There's a centrifugal force, so the mass of the inertia base helps to dampen some of that, and then the whole thing is mounted on springs. when you're selecting a fan, smaller fans are usually mounted on rubber mounts, but the bigger ones would be on springs. The amount of vibration isolation is directly related to the amount of compression, or static deflection they call it, of the anti-vibration mounting. And you'd also be aware that flexible connections are normally installed between fans or fan coil units and the adjoining ductwork. So this is just a short section of, it's usually like, we used to call them canvas. They don't really use canvas anymore. They use a polyester material, but it's only about 100 to 150 millimeters long to give vibration isolation between the fan and the ductwork. So you've got the springs or the rubber, so that it's allowing the fan to move. As it rotates, it's going to vibrate a bit. So the springs and the rubber allowing the fan to do that. But because it's moving a little bit, the vibration is set up that will enter the ductwork unless you have a flexible connection there. So if that's all done correctly, that will eliminate the vibration into the ductwork. But the flexible connections need to be installed in the correct location to ensure that the fan performance is not adversely affected. So what I'm saying there is, particularly for axial fans, if you put a flexible connection at the inlet to an axial fan, that's a problem, because the negative pressure at the fan inlet will pull the flexible connections down and create a disturbance at the inlet, which will cause turbulence and will affect the fan performance. So with an axial fan, you need to move the flexible connection back on the inlet side at least, past the transition or the first piece of duct, put it back there so that any disturbance of the air straightens out again before it enters the fan. If you look in the Fantech catalogue, there's a section on fan do's and don'ts. Have we talked about that before?
Maybe briefly. I'm not sure. I think I remember something on this subject. I'm not sure if it was with you, Peter. Maybe it was with someone else.
I'll have a look and see if I've got something. We have talked about fans, haven't we? So install tips, I've called it. So this is from the Fantech catalogue. They've got some good information in there. Flexible, so you can see on this one. See where they put the flex, it's an axial fan. There's a transition, they put the flexible connection back here. On this one, don't do this. Don't have a sharp bend, a flexible connection, and straight onto the fan. The point I'm making here is the location of that flexible connection should be a duct length back, or the transition. If you're having a transition into from a rectangular to a circular fan, put it upstream of the transition. On the discharge side of the fan, it's not a problem to put the flexible connection right at the fan, as they've indicated here, right on the discharge, because on the discharge side, there's a positive pressure, which is going to tend to force the flexible connection out. So you've still got a clear passageway for the air to go through. But if you have it at the inlet, it'll pull it in, and that's a problem. So that's a pretty standard thing you'll come across in the industry. If you're using an inline centrifugal fan, you know, the box fans with inline centrifugal, we've talked about these before. It comes in a box, but it's got an inline centrifugal fan wheel inside it. You can put the flexible connections at the inlet to those. That won't affect them because of the type of fan it is, but axial fans, it's critical to get them in the right position. Now, we won't go on to part 2 because we've run out of time. I thought we would. I was going to talk to you more about sound attenuation. So we can do that next week, unless there's something else that you want to talk about. Have you got any questions on where we're up to so far?
No, I don't have any questions.
No. Pretty
Okay.
comprehensive.
So what I propose, and once again, it's up to you guys. You know, if there's something you want to ask me about, just bring it up, and you don't have to give me any warning. Just have it ready, and we'll talk about it. That's fine. If we don't do that, we'll talk about sound attenuation, and then we'll go on to talking about attenuators. I know as part of our value engineering process, we try to eliminate as many attenuators as we can by using internally lined duct or designing the ductwork so that noise is not an issue. But sometimes we will have to use attenuators. So you need to know about them and how to apply the different types and how to select them and how to apply them. So we'll talk a bit about that, but not in huge detail because you're probably not doing that at the moment. So it's just an awareness thing. And so hopefully that'll be worthwhile to do that for you. And we'll do that next week.
Sounds good.
Okay.
Yeah,
Are you
thanks,
right?
Peter.
You right to save this, Jess?
Yeah, hopefully I can download it. If not, I'll
Just
send you
let
a
me know.
message. Yeah.
If you can't do it yet. Okay. All right. Thanks, guys.
Cheers for you.